So here's a little piece of rock salt, right? So a very versatile chemical. Salt helps our food taste better. We can also mix some salt and ice and pack it around cream and make ice cream. So the salt is there to make things colder, get it cold enough temperature so you can make the ice cream. We also spread it on our driveway in the wintertime, and that helps melt the ice, right? So the interesting question I would say is, how is this thing that makes your salty mixture colder also melting your driveway, right? Feels like one should be colder, one should be warmer. Interesting bit of science there. So this here will represent our salt. So regular salt is sodium chloride. That is what it sounds like, one sodium atom for every one chlorine, right? This is called the red's sodium and the blue's chlorine. A actual salt crystal about the size of this one here is going to have just millions of atoms, so tons more, much larger, in 3 dimensions, a lot of sodiums and chlorides. As a solid, they're all packed together tightly. If we mix our salt crystals in with some water, right, so these will represent our water. The water is a liquid and it's flowing and moving around the salt, and it'll actually work to dissolve and pull apart all of these atoms and mix and incorporate in between. So when we dissolve salt, we're literally taking this crystal where everything's packed together and pulling it apart. When you make ice cream at home, you mix some rock salt and some ice together, and some of the water from the salt will dissolve that salt, and it actually ends up getting colder. So as you're dissolving and separating these ions apart, it's getting colder. Well, temperature, the temperature of the liquid, temperature of the water, is really sort of how fast it's moving. Right, so hotter temperature, those water molecules are going to be moving a lot faster. Colder temperature, they're going to move slower. Right, they use up some of that energy in separating out the salt crystal, separating out all the atomic components, and then you end up with a colder solution. The other key to it, which is then relates to the using rock salt for the driveway, is, well, it can't get colder than freezing unless it has the salt in it. So you make a colder than freezing water temperature solution. It's actually lower than the temperature it would normally need to be to make ice. And that's because the mixture of the salt and the water freezes at a lower temperature than regular pure water. So we have this extra cold liquid that has dissolved the salt in it. So when you're using rock salt to clear your driveway, and you're trying to get all the ice off the driveway, I got a nice little pile of rock salt here. What we're really trying to accomplish is a wet slush of salty water all along the driveway, right? Or all along the roadside for the trucks that spray and go by. And so you toss it down, right? It mixes with some water, and then you get some salty water all covering the road. And this is good because, again, the salty water doesn't melt as easily. So the snow comes down, it mixes with the salty water, and it'll dissolve instead of freezing. Right, so we're basically just trying to prevent freezing by having salt water all over the place instead of just water. If it was just water, it would freeze once it drops below 32 or 0 degrees Celsius. If it's salty water, it's got to get even colder for that. If it gets too cold, it'll freeze anyway. And in that case, salt doesn't work, and you use things like sand. So really, you've just lowered that freezing point of water by adding salt to it. And for home buyers, for things you can get at home, there's a whole bunch of different products now. You can see the ratings for temperature are usually pretty accurate. So if you buy something that works in colder temperatures, it has different salts in it that work a little bit better. They'll lower the freezing point of water even more. Things like calcium chloride and magnesium chloride Those are good to add into de-icing and ice melting mixtures. There's a whole ton of other products though too. There's Pet Safe, and you see blue salt on the sidewalk and orange. And best thing I can really figure is most of that is just marketing. There's a lot of different formulations you can have. Some may not work that well. Some may work a little bit better, but maybe not worth the price and things like that. The color added to those different salts doesn't really mean anything. It just identifies the products. It's probably just additives as far as that goes. Just about anything that dissolves in water can potentially work as an ice preventer on roads. You may have heard stories about beets and beet juice, or just all sugar and things like that being sprayed on roads instead of salt. At some point, putting too much salt down, can be a problem for water and vegetation and such. So, coming up with an alternative is not necessarily a bad idea there. But really, chances are the simplest thing is just having salt on the road is going to work and prevent ice from forming, as long as it doesn't get too cold. But anyway, thanks for watching. If you have any other questions or other specific things, please ask as a comment or send to the library or myself. And please come up with more concept video ideas. I'm happy to talk about just about anything. And there's a fun claim, which I'll read, um, from one of the brands I found on the internet, which contains urea and propylene glycol, and actually it's probably not very pet safe, it's, at least in terms of your pet eating it. Stepping on sharp, salty rocks tends to be the concern, but it says patented dual effect compound made of a modified crystalline amide or core. So, okay, patented dual effect compound made of a modified crystalline amide core infused with special glycol admixture and detection agents, quickly melts ice and is safe for pets, humans, vegetation, and the environment. Right? Even I had trouble saying that semi-scientific sounding nonsense. What is a modified crystalline amide core? They're probably talking about urea, which is that molecule that's not particularly good at dissolving salts. But there's a lot there. If you put some salt on your driveway, it'll probably work. And maybe now you understand a little bit better why it would work. Is pretty much the lesson here.